So here's an example of a partial fractions that has a quadratic. So when you set up your two partial fractions, you have x squared plus 1 plus, and then you have x squared plus 1 squared, because those are the two possibilities of the two separate fractions you could have had for that. Because the bottom is a quadratic, instead of just an a on the top, I have to put ax plus b. So then when I start this one, I have to start with c, but again, this is a quadratic. Now, if this was not a quadratic, I could just do plus c. But since this bottom is also a quadratic, I have to do cx plus d. So now I do the process of common denominators. What does this one need to be the same as that? It needs x squared plus 1 on top and bottom, x squared plus 1. What does this one need to be the same as that one? It just needs a 1 to multiply by 1. Now I'm going to do the process of that, and then again, once I do, I don't need the bottom, so all I need is the top. So I'm going to rewrite that. 3x, oh, I copied that wrong. That's supposed to be a third power. 3x to the third minus x squared plus 5x plus 1. So then I'm going to take just the top, ax plus b times x squared plus 1 plus cx plus d times 1. Now I'm going to multiply it out. So I have to basically do FOIL. So I have ax to the third plus ax plus bx squared plus b plus cx plus d. All right, I did all the multiplying. Now I'm going to group by exponent. So the first exponent that I have is ax to the third. Then I'm going to do my x squareds. I only have one of those, so bx squared. Then I'll do my x terms. Oh, I've got two of those, so ax plus cx plus then my constant term, a b and a d. Now I'll be able to equate the coefficients. Oh, but this one's got two x terms, so when that happens, I need to factor that. So we're going to do one was, if there were 2x to the thirds, I'd factor that. But I don't have 2x to the third, so ax to the third plus bx squared plus x times a plus c plus b plus d. Now, hopefully you can see how similar these two sections are. I have an x to the third term, I have an x to the third term here. So what must we know about those coefficients? Right, they have to be equal. So, a equals 3. No solving there. All right, the x squared coefficients must be equal. So, b has to equal -1. The x coefficients have to be equal. So the coefficient of this x is 5. What's the coefficient of this one? A plus c. So a plus c has to equal 5. Oh, that's easy. If a is 3, subtract 3, c equals 2. So now I can find c. All right, and b plus d, what does that have to equal? 1, right? But I know b is 1, so d has to equal 0. I think. Hang on a second. Let's do that. So b is, oh, it's -1. So then I add 1 to both sides. Ooh, d equals 2. It's a good thing I did the arithmetic on that one, so be careful. Because sometimes I'm going to add 1. Add 1 to both sides there to solve that. Because that was -1 plus d. Okay, so I've got all my answers here. So how does this get me to the final answer there? Let me erase this work here. You should try to work this problem out yourself and then check my video for the final answer. All right, so originally we had, without the common denominator stuff, we had ax plus b over the first fraction plus cx plus d over the second thing. We had x squared plus 1, and then we had x squared plus 1 squared before we did the common denominator thing. So, I know that a is 3 and b is 1. So this would be, b is minus 1, so this would be 3x minus 1 over x squared plus 1 plus, and what's my c is 2, so that's 2x, and my d is 2, so 2x plus 2 over x squared plus 1, the quantity squared. And there's the original partial fractions that when you get common denominators and add them together, that's the top. And you can check that out to check your work if you want. And if it works out, then you know you have the correct answer. How would I check this? Well, this would need to be multiplied by x squared plus 1. So if I multiply 3x minus 1 times x squared plus 1, and then add all my like terms, I should come up with this top here. And you can check that, but I won't. Bye.